to Cinderella Math. Today I'll be doing a study guide for the first test or first exam in a Calculus 3 course. It is currently spring semester 2026, but math doesn't age too much, so if you're here later in time, it should still be pretty relevant. The topics, they're pretty wide. It's mostly like vector calculus and also like converting coordinates from one coordinate system to another. Yeah, so I'm not going to be going into like the nitty gritty of like the why behind all the problems. I'm just basically going to be doing them. I'll explain maybe a little bit here and there, but there's other videos with other instructors that can definitely give the why better than I can. I'm going to be cranking the math. All right, let's do it. Let's go. Alrighty. I have already done these, so you'll see they all have checks and the answers are in there. I'm just going to cover that up as I do them again. All right. So you can see here we have two curves given by vector r1 of t and vector r2 of t. We are told they intersect at the origin, and we need to find the acute angle of intersection. So acute, under 90, I would think. But it does say in radians and round to 2 decimal places. All right, so we'll need the calculator, but I'll cover it up for now. All right, so again, I'm not going to go into the nitty-gritty of why. I'm just really going to be doing the mathematical processes here. So we are told they intersect at the origin, so in 3D space, because you can see we have 3 coordinates here. The origin is 0, 0, 0. So we need to ask ourselves what value of t would make r1 of t be 0, 0, 0. So when is r1 of t equal to 0, 0, 0? Sorry, and it technically should be like, well, it's fine. So what can we plug in here? That this would be 0, this would be 0, and this would be 0. 0, right? So when t is 0. So we do have r1 of 0 would be negative 5 times 0, 0 to the 5th, and then negative 0 to the 3rd, which is, of course, 0, 0, 0. There is no negative 0, right? Okay. Now ask yourself the same thing for vector 2, R2. When would this one give us 0, 0, 0? You really need to look at this z component, the third one. When would t minus pi be 0? Solve. Move that over. T equals pi. So question, when is r2, the vector of t, equal to 0, 0, 0? Answer, when t is pi. And it really comes from that third component. So just to prove that to you, we have r2 of pi would be sine of negative 5 pi sine of 2 pi and then pi minus pi. Okay, I just plugged in pi there. All right, so this would be, think of unit circle here, negative 5 pi. So go in the negative direction, so clockwise. So all the way around clockwise, that's negative 2 pi. All the way around again would be negative 4 pi. So halfway around right there would be negative 5 pi. And that point is negative 0, 1, CS, and we need sine. So that would be 0. And the next one, sine of 2 pi. So unit circle again, but go in the correct direction, so counterclockwise. Against the clock once. That is 2 pi. And that point is 1, 0, CS, so that is 0. And pi minus pi is 0. Yay. Now that part, if you can do that in your head, you don't really need to show that workout. Okay? You can, but it's not like vital to the problem. You do just need really those t values. Okay, so we had R1, our magic t value was 0, and R2, our t value was pi. Now you're going to go ahead and take the derivative of both of those. So let's take R1 prime of t. So derivative of negative 5t would just be negative 5. Derivative of t to the 5th would be 5t to the 4th. And derivative of negative t cubed would be negative 3t squared. Now go ahead and plug in our magic value of t for this one, which is 0. So do R1 prime of 0. Well, there's nothing to plug in on the first one, so that would say negative 5. Then this would be 5 times 0 to the 4th, and negative 3 times 0 squared. So this is negative 5, 0, 0. And then hold that one. Okay, let's do the same thing on R2. Let's take the derivative. So R2 prime of t. Derivative of sine is cos. Keep the argument times derivative of the argument, which is negative 5. Okay, and then do that again. Derivative of sine is cos. Keep the argument times derivative of the argument, which is 2. And then derivative of t is 1. Derivative of pi is a number, a constant, so that would be nothing. So there is our R2 prime. And now plug in that magic value of t, which we found to be pi. So we're going to do R2 prime evaluate at pi. So that would be negative 5 cos of negative 5 pi to cos of 2 pi. And then there's nothing to plug in on this one, so it just stays 1. Okay, back to unit circle. We said negative 5 pi was here. There's the point CS, so we have negative 5 times negative 1. We said 2 pi was here, CS, so we have 2 times 1, and then there. So this is 5, 2, 1, and hold that. All right, I'm going to have to do some erasing, so pause me if you're copying any of that. The question is find the acute angle between these two. Okay? The angle of intersection between these two curves. All right, so we need a formula now. So if you're allowed a formula sheet, this should go on it. All right, none of this we need anymore. Okay, just those two answers. Okay. Here is the angle formula for the angle in between two curves. It's the cosine of that angle theta is the R1 prime dot the R2 prime over the magnitude of the R1 prime and the magnitude of the R2 prime. Okay, so we're going to dot our two previous answers. So I'm doing the red answer dot the blue answer. So I might as well go to purple, red and blue, right? So that would be negative 5 times 5 plus 0 times 2 plus 0 times 1. So that's negative 25. Okay, that's the dot product. And now on the bottom, we're going to do the magnitude, so the square root of each component squared. So for R prime, so the magnitude of the red, that would be negative 5 squared plus 0 squared plus 0 squared. And then for the magnitude of the blue, R2 prime would be 5 squared plus 2 squared plus 1 squared. So this one would be square root of 25, which is just 5. And this one would be 25 plus 4 plus 1, so 30. All right, so we now have cos of theta is, look at negative 25 over 5. You could divide that. That's just negative 5. If I could write neatly. Over cos, no, square root 30. Inverse cosine, inverse cosine. Theta is inverse cosine of negative 5 over root 30. And now the directions did say to like round off. So at this point, we'll go to calculator. There's an inbuilt calculator into this program. It's Desmos. It should already be set into radians. And we're going to do inverse cosine, or you can just type arc cosine. Either way. Let me see if I can get this to... You can do the keyboard if you want. Functions, and then there's inverse cosine. Or you can just type arc cosine. Either way. And then parentheses, ours was -5 over, there's a square root button right there, or you can type SQRT, and that was 30. There is the answer. There's theta. Oh, where's my pen? So theta equals 2.72, rounded. But the question said give the acute angle in between 0 and pi. Now that is in between 0 and pi, right? Because pi is 3.14. But it is not acute, right? So acute, if you're thinking degrees, acute needs to be less than 90 degrees. If we turn this radians into degrees, you would do 2.72 times pi over, times 180 over pi, and we get 2.72 times 180 over pi. That's how many degrees that is. That's not acute. Okay. So we have two curves here intersecting. I know that's not a curve. Well, I mean, whatever. That's 155-ish. Let's get this one. That would be the acute. And remember, a straight line makes a 180. So if we just do our answer theta, and we do 180 minus that, right? Right here, pi, in radians, right? Because think of the unit circle. This straight line is pi. So we're going to do pi minus our answer to give us the acute angle. Okay? So I'm just going to go back up to this and just type in before this, I'm going to do pi, pi, minus. There is the acute. So final answer, theta equals 0.42. Now, just for kicks and giggles, if you turn that to degrees, you would do 0.42 times 180 over pi. Let's see if that's acute, just for fun. So 0.42 times 180 over pi, and that is acute. Yes, it's 24. Okay, great. So final answer, 0.42, and we had to do that one extra step because they wanted the acute angle. There we go. Number 2. Convert that point into spherical coordinates. All right. We have some formulas we need to know here. So this is just our normal point, rectangular, if you will, Cartesian, x, y, z. And we're going to spherical, p theta, is that phi? I can never remember what that one's called. It's fine. Here's the formulas you need to know. So again, if you're allowed a formula sheet, let's write these down. Oh, it's rho, isn't it? Rho squared. The rho is what p is, I'm pretty sure. Equals x squared plus y squared plus z squared. Cos of phi, actually, do that one last. Tangent of theta equals y over x. That should be familiar from if you've done polar coordinates. And finally, cos of phi, I'm pretty sure that's phi, equals z over the square root of x squared plus y squared plus z squared. So these are the formulas we need to know to go from Cartesian or rectangular into spherical coordinates. All right, so our rho squared will be -1 squared plus 1 squared plus 3 squared. So rho squared is 1 plus 1 plus 3. 9. So rho squared is 11. So rho is root 11. And if you put that in a calculator, it rounds off to approximately 3.31. Okay, tan of theta is y, so 1 over x, so negative 1. So tan of theta is negative 1. So theta is inverse tan negative 1. Now, when I tried to put that into this program, it did not take it. So I just went ahead and worked that out. So we need to think about unit circle. When is tan negative 1? So remembering that tan is sine over cos, or tan is y over x. Right here is root 2 over 2, root 2 over 2. So that tan would be 1. But if you just come over here, if you kind of reflect that into quadrant 2, this would be negative root 2 over 2, regular root 2 over 2. So if you did y divide x here, this would be negative 1. And this angle here in radians, this one's pi over 4. That gives us the 1 as a tan. This one's 3 pi over 4. So theta is 3 pi over 4. And again, I don't know why it didn't take this, because that's technically correct, but it did take this one. And finally, we have cos of phi, sorry if that's not how you say it, equals z, so 3 over the square root, excuse me, of negative 1 squared plus 1 squared plus 3 squared. We already did that up at rho, so we get cos of phi is 3 over root 11. Take the inverse cos, take the inverse cos, and now this one it did take. So I just said phi is cos inverse of 3 over root 11, and it did accept that. So I don't know why it didn't accept the tan, but it did accept that one. If you did want to put that in a calculator and round off, that is approximately, I have it written down, 0.44. Yes, 0.44. And I guess technically you could round off 3 pi over 4 too. So if you want to round that off, it would be, let me grab my calculator, 3 pi over 4, approximately 2.36. Okay, so now, again, there's a couple different ways you could write this, but this is what I did so that this program here, Lumen, accepted it. So I got for rho, I got root 11. For theta, I got 3 pi over 4 once we evaluated that tan inverse using our unit circle knowledge. And for phi, I got cos inverse of 3 over root 11. That's the answer I put in that they accepted. Okay. And there it is. I put arc cos, but cos inverse would be fine. And I think on the button here, they have all the decimals. But they don't, it does say to one place, but I don't know. Anyway, number 3. All right, easy peasy here. This is just finding the derivative of a vector value function here. So we have an r of t, and the question is find r prime. So just take the derivative, each one individually. So this derivative would just be 4t to the third, because the derivative of 3 would be nothing. This derivative, e is his own derivative, right? So it would be negative 4e to the 5t times derivative of power, which is 5. And then derivative of negative sign is, so regular sign's cosine. So negative sign would be negative cos, keep the argument, times derivative of the argument. And then let's just clean that up. The first one's fine. Negative 4 times 5 is negative 20, e to the 5t. Negative times negative would be positive cos. Put this 2 in front, it'll look better. And keep the argument. Answer. All right. Number 4. We are converting the other way this time. we are given the point in spherical coordinates, and we need to put it back into Cartesian x, y, z coordinates. So we do again have some conversion formulas that you want to write down. X is rho sine phi cos theta. Y is rho sine phi sine theta. And z is rho cos phi. So again, write those down. And then once you have those written down, it's not that bad. There's phi, there's theta, there's rho. So x is 5 sine of pi over 6 cos of 11 pi over 6. All right, let's go to unit circle. Pi over 6 is your first one up in quadrant 1. And that point is root 3 over 2, 1/2 CS. And 11 pi over 6 is your first one down in quadrant 4. 11 pi over 6. So that's still root 3 over 2, and then it's down 1/2 CS. Okay, so now we have 5 sine of pi over 6, so that's the top one, so that would be 1/2. Cos of the bottom one is root 3 over 2. Put this over 1. Go right across the top. We would have 5 root 3. Right across the bottom is 4. There's our x. Yes, you could go in the calculator and round it off. I think that's prettier just to leave it like that. It is approximately 2.17, but I would just leave it. Okay, coming to y. Just follow the formula. Rho, so 5 sine of phi, so the last one, sine of pi over 6. And then sine of theta, the middle one, 11 pi over 6. So now we have 5 sine of the top angle, so 1/2, sine of the bottom angle, so -1/2. Give him a 1, go right across the top would be -5, right across the bottom is 4. There's your y, and again the decimal would be -1.25, but again I just leave right there. And finally z. Rho, so 5 cos of phi, the bottom, the last one, the third one, so pi over 6. So this would be 5, and cosine of pi over 6, look at our unit circle, is root 3 over 2. Give this a 1, and we get 5 root 3 over 2, which again is approximately 4.33, but I would just leave it. So our final answer, x, y, z, I've got 5 root 3 over 4, -5/4, and 5 root 3 over 2. And there we go. Not bad. Once you have those formulas, it really goes. Number 5. We have two vectors, an A and a B, and we are finding the projection of B onto A. And that's what it kind of looks like there. And our answer will also be a vector. Okay, here's a formula we need to know. So it's projection, and then the one that's of, it stays big, and the one that it's onto is like the subscript. Okay? And then this equals, do them dotted, and then do the little one, so the subscript, so the A1, you're going to take the magnitude of that and square it. Let me actually erase part of this box. Okay. And then you're going to take all that and times it by the vector of the little one, so A. Okay? So again, the of one goes big, and the onto is the little, and it's the dot, magnitude of little squared times the actual little. And by little, I mean the one that's the sub. Okay, so let's dot A and B. So A dot B would be -1 times 2 plus 5 times 3. So that's -2 plus 15, so 13. Okay, that's going to be the top of our fraction. And now let's do magnitude of A. So that's the square root of each component squared. So -1 squared plus 5 squared. So that would be root 1 plus 25, so that would be root 26. Okay, so we have the dot was 13, the magnitude was root 26, but look, this is magnitude squared. So we're going to square that and then times that by a, which is the vector, -1, 5. Well, the square and the square root will just cancel. So we have 13 over 26, but wait, reduce that. That's a half. So we have half times our vector. We are allowed to multiply a vector by a scalar. It's basically just distributing. So we're going to get -1/2, 5/2. That is our projection. So again, once you have the formula, it goes. So write that formula down, that one in the black there. All right, now we're doing a 3x3 determinant. If you've had linear algebra, this should go pretty nicely. And they want you to do a cofactor expansion on row 2. Don't know if that's the row I would have picked, but we'll follow their directions. It's fine. Alrighty. Alright, so we're looking at row 2. Let me kind of give him a highlight here. That's what we're expanding around. So you look at what position your first thing is in. That's in the second row, first column. So that is in position, how do I write this? This position right here is 2, 1. So now we do that, we do -1, and you take those two numbers I just said, second and first, so 2 and 1, and you add them as the power of -1. Don't know why my pen is so fat. Let me make it less fat. Okay? And then you times by whatever number is in that position. So we have a 1 there. Oh, I didn't mean to get my highlighting gone. Let me just take the red off. There we go. So we have a 1 in that position, and then we do the determinant of the cross. So what's left? -2, 0, -12, -6. Okay? And then we'll figure that out in a second. Now we want to come to the next number over. So it's this one right here. What position is he in? Second row, second column. So we're going to do -1, second, add, times that number, which is -1, and then the determinant of what's left after the cross. So what is left? 1, 0, 6, -6. Okay. And then, trying not to get rid of my highlighting. Okay. It's fine. Go over to the last number. What position is he in? Second, third. So it'll be -1, 2, 3 plus times that number that we're targeting here. So we're targeting 0. Determinant of what's left. So what is left? 1, -2, 6, -12. Okay, now let's just work that out. That's a cofactor expansion. Okay, so right here, I'm going to come down for room. That'd be -1 cubed, which is -1 times 1, so that's -1. And then doing this determinant, you go crossways, multiply, that's 12, always minus, multiply, that's 0, plus. -1 to the 4th, right? That would be -1 to the 4th, so that's 1 times, what do we have there? -1, so that's going to be -1, and then let's go this determinant, go crossways, that'd be -6, always minus 0. Plus, this would be -1, the green, to the 5th, so that's -1 times 0, so that's going to be 0. This determinant, this one really doesn't matter because it's going to be 0. -12, always minus -12, which will turn to plus. Okay, and now we're just evaluating here. So that'd be -1 times 12 plus -1 times -6 plus 0 times 0. Again, this one you really didn't even need to do because it was going to be 0. So that's negative 12 plus 6, which is negative 6. There is the final answer. That is the determinant of that 3 by 3. Okay. And you can do that around any row or column, actually. They just told us to do row 2. Alrighty. We are given a vector. Find the magnitude and the angle in which the vector points, measured clockwise from the positive x-axis. Okay. So our vector, u, is negative 1i plus 4j. I like to write it in this form, negative 1, 4. And now let's do magnitude. So that's the square root of each component squared. So that's negative 1 squared plus 4 squared. So that would be 1 plus 16. So our magnitude is root 17. And you can see that up there, and that's correct. Yes, you could round that off, but I wouldn't. I would just leave it. And then the angle in which this points, so if you think about it, our vector is this or this. From the origin, that means we're going left 1, up 4. So there's our vector. You can drop a triangle. There's our theta. That's what we want, theta, the angle. So this was left 1, up 4. So SOHCAHTOA, the tangent of our theta is the y value, the 4 over the x. So 4, negative 1. So we have tangent is negative 4. Take the inverse tangent. So theta is inverse tangent of negative 4. Now I tried to just put that in for the answer and they wouldn't take it. So let's go to the calculator on that. Again, I think we do need to be in radians, and it should be. Your calculator should already be. Okay, see, that's why I guess they didn't take it, because it's negative. So look, it says it needs to be between 0 and 2 pi. This isn't, because it's negative. So whatever this angle is, it's negative 1.32, blah, 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 blah. Let's add a whole circle to get it positive. So I'm just going to take that previous angle and add 2 pi to get a coterminal angle. And no, that's not right either. What'd I do? No, add pi. I'm sorry. Just add pi. There we go. And then I tried just doing 1.82, and they wouldn't take it. They wanted the whole answer there. So I don't know why. There you go. So again, it was a negative answer, and I just added pi to get another angle that would have that same tan. And again, I tried to just do arctan negative 4, but I guess they didn't like that because it technically came out negative, and they wanted a positive angle. Okay, so I'm not totally sure on the why of that one. Number 8. Find the acute angle in degrees, so flip your calculators to degrees, between these two planes. All right, I did have to kind of watch a video on this one to understand the process. It's annoying for sure. Number 8. All right, let's see. So the angle, here's a formula that you will want. The cosine of our angle is the absolute value of the normal vector 1 times the normal vector 2, or dotted normal vector 2, all over the magnitude of normal vector 1, normal vector 2. So that looks like a formula we've already written down, like let me see what number it was. Number 1. It looks very similar to what we did on number 1. But what do we mean by the normal vectors? They got those by just, let's see. No, they are just the coefficients of the planes that are given. So our normal 1 is going to be the coefficients of this, and you don't need to worry about like the answer, just the coefficients. So negative 3, negative 5, 5. And our normal 2, just again, pull these coefficients. Negative 5, 1, 2. Okay, so now let's dot those. So we have cos, my pen is being weird, cos of theta is absolute value of this dot, so that would be negative 3 times negative 5 plus negative 5 times 1 plus 5 times 2. So that's absolute value of 15 minus 5 plus 10. So that's absolute value of 20, which is 20. There's our top. And now let's do the bottom. So we'll do the magnitude of n1. So that's going to be negative 3, the root of negative 3 squared plus negative 5 squared plus 5 squared. And then magnitude of n2 would be square root negative 5 squared plus 1 squared plus 2 squared. So this would be 9 plus 25 plus 25. So this is going to be root 59. And then this one would be root 25 plus 1 plus 4. So that's going to be root 30. You can multiply roots. So we are now at cos theta equals 20 was the answer on top. Multiply 59 times 30 and you get root 1770. So our theta, take the inverse cosine. Theta is inverse cosine of 20 over root 1770. Put that in the calculator and make sure it's set to degrees. So let's do that. Calculator. Let me see, can I get this Desmos? You want to hit the wrench, set to degrees. Okay, and then it was inverse cos of 20 over square root 1770. So it looks like 61.62 in degrees, rounded to 2 places. And there we go. I'm going to set this back into radians. Actually, no, because every problem has its own calculator. It's fine. Here we go. That was number 8. Number 9, they were asking for a cross product. So pretty easy as long as you know how to do that. It goes pretty nicely. I don't know what's going on with my pen. I might try to get through 10 so I have like a good stopping place and then restart the video. Just having issues with the pen, sorry. Alright, so again, here's u, but I like to write it like this. So that would be 8, 7, negative 6. And here's, v's already written like that, so that's great. And we're going to cross. So you're going to make a 3 by 3 determinant where your first row is I, J, K. Your second row is going to be the u coefficients, so 8, 7, negative 6. And your third row will be the v coefficients, so negative 6, 2. Okay, and now do the cofactor expansion, always with the first row. And if you just always use the first row, you don't have to do the negative 1 thing. This one will just be regular I, then it'll be minus j and positive k if you always just use that first row. Okay, if you cross out I, what's left? Like that. So 7, negative 6, 2. Right, so I gotta, sorry. Alright, I don't think crossing out's gonna work. Sorry, 1 second. Trying to show this in the best possible way, but. Okay, now if you cross out J, what's left? So you would still have that 8, negative 6. He's still back, I just can't erase. And then you'd have negative 6, 2. And then if you cross out K, anything that doesn't have blue on it would be 8, negative 6, going downward, 7, negative 6. This pen, oh my gosh. All right, now we just need to evaluate that. So we would have I times, go crossways, that's 14, always a minus, go crossways, that's 36, minus J, go crossways, that's 16, always a minus, go crossways, that's 36, plus K. Oh my gosh. This will be my last question. I need to restart the computer. I don't know. My pen's going crazy. Go crossways, negative 48, always a minus, go crossways, negative 42, turn to a plus. Okay, let's just evaluate that. So that's I, 14 minus 36, what is that? Negative 22. Minus J, 16 minus 36 would be negative 20. This pen is just having a connection. Plus K, and then add that, because minus turn to plus, that would be negative 6. So our final answer, the component of I would be negative 22. Oh my gosh. Comma. The component of J, see how that's negative, negative? So that would actually turn positive 20. And the component of K is negative 6. And you do want to input that in component form here. All right, I'll have to do a part 2 because the pen is just, it's gone. So I will make a note that I did 1 through 9. I hope this has been helpful so far, and please keep your eyes out for part 2. And if that one's long or the pen starts going, it might even go to a part 3 because there are 30 questions. So I almost got a third done. All right, let me know if you have any questions. Hope you're having a good day. Bye-bye.